With the tool of de-extinction at our fingertips, we could have the power to alter the course of natural history. Animals that went extinct 100 years ago, nay, 1,000 years ago, nay, 100,000 years ago, could all again be a reality today.
The idea of de-extinction first began when people in 1993 went and watched Jurassic Park. However, the idea first began to materialize when scientists cloned Dolly the sheep in 1996. In many ways, Dolly was the harbinger that allowed scientists to begin experimenting with de-extinction.
Dolly the sheep was brought back with a method of cloning where the DNA of a sheep was implanted into an embryo, which in turn was planted into a surrogate mother, creating a clone of the original sheep. The same technology allowed scientists to bring back the Pyrenean ibex back in 2003, an animal that had just gone extinct 3 years prior. Using the frozen DNA of the last ibex that was captured in 1999, scientists were able to implant this DNA in an embryo. This embryo was then placed into hybrids of the Spanish ibex and domestic goats. While the infant was only able to survive for a couple of minutes before it died from defects in its lungs, it was still a testament to how far this technology had come and how far we would be able to take it in the coming years.
As technology advanced, CRISPR and the Cas9 system were developed to enable precise genome editing. This system is an editing tool for DNA, able to go through millions of strands of DNA, locate a specific gene, and then remove or add to it. This technology first became exploited in 2008 and was later implemented by Revive and Restore. Using genome editing and the Cas9 system, Revive and Restore was able to analyze and compare the genomes of the passenger pigeon and the band-tailed pigeon, which are the closest species we have currently. They would then be able to find out which parts of the genome are responsible for giving them their differences. After comparing these two genomes, the scientists are able to edit the specific parts of the genome that differentiate these two species. For example, if we could identify what gene gave the band-tailed pigeon its distinct tail, we could edit it with the help of CRISPR and change it into something that would more resemble the likes of a passenger pigeon. While the results from this would never be perfect, with the technology we have now, this is as close as we can get. As the interest in de-extinction increases and the technology becomes more accessible, scientists will be able to bring back animals more easily. De-extinction could encourage the development of new genetic engineering techniques. This process could advance these techniques needed to add insight on new technology that may be developed further down the road. These genetic engineering technologies could be applied to endangered species outside of just extinct animals, as well as help reduce issues revolving around the number of predators and prey. For example, bringing back certain extinct species, such as the saber-toothed tiger, would lead to the balance of predators and prey, as the common prey for a saber-toothed tiger were herbivores. It could also increase the wildlife in our environment, as well as severely reduce the numbers of species dying off due to human actions. Not only can we prevent extinctions from beginning, but we could also apply this knowledge to make improvements in animal health. For example, in the future, on top of being able to bring back extinct animals, scientists could also prevent animals, such as birds, from catching viruses like the flu.
While de-extinction does bring a lot of exciting potential, it is important to note the risks and implications that this technology might bring. One of the greatest concerns is that the public will absorb the impression that extinction is no longer scary, that the mindset will become, if animals go extinct, no problem, we can just de-extinct it. Once this becomes the mindset, priorities in conserving present species will fade, and the amount of species we drive to extinction might be far more than the amount we are able to bring back. On top of this, the cost and resources required to bring back a species is far higher than preserving current species. For example, the costs and resources of bringing back 5 extinct species is equivalent to the amount required to preserve 42 living species in New South Wales. Furthermore, there may be a possibility that the de-extinct species could cause a threat to our current ecosystems, disrupting food chains and changing the natural landscape in ways that can be very hard to predict. On top of the risks that might be presented with de-extinction, there are also a lot of ethical concerns that are raised when considering the implications of this technology, namely the concern of humans playing God. While de-extinction does give us the opportunity to rectify our past actions and create more biodiversity, many species were driven extinct as a result of Mother Nature's decline, some as a result of habitat loss, and others purely by chance. Either way, these circumstances were the result of natural order, and bringing some of them back could be seen as an act against nature.
Phew.
On top of this, every animal born from de-extinction will ultimately be born in captivity, at least in the foreseeable future. For example, Revive and Restore's woolly mammoth program, even if proven successful, would still have to be kept in zoos until they're able to establish herds in colder areas of the planet.
While there are a couple repercussions with using this tool, we need de-extinction as it could improve biodiversity by diverting resources from preserving ecosystems and preventing new extinctions. It could also reduce the weight of extinction overall and support the endangered species and help with the development of technologies to advance on topics to create more impactful changes to the environment and the world. This could be a starting point to a whole different reality.